So I wanted to make this video to give a couple of samples of how to do these types of problems when you're going between atoms, like the number of atoms or the number of formula units of a substance, to the number of moles, to possibly the mass. All right. So just a quick overview. When you're talking about the number of atoms or the number of formula units or the number of molecules, literally what you would be talking about is if you could had if your vision allowed you to see the individual atoms of a substance and you could count those, how much would that be? All right. Hopefully you realize that, for example, like my ring, for example, the number of atoms would be huge. All right. Like there would be billions upon billions if in even a small sample of it. All right. When you're talking about mass, you're talking about like what you could weigh. If you put it on a balance, like how many grams is that? By perspective, if you have a sugar packet, the amount of sugar in a sugar packet is about 1 gram worth of sugar. All right. And mole. All right. Mole it's similar to the number of a substance, but the analogy is like dozen. All right. Whereas atoms is like how many individual particles. For example, with these rice grains, number of rice grains is 12. All right. But the number of moles is 1. All right. And moles is just like gram, except for instead of 12, mole means 6.02 times 10 to the 23rd. All right. So you'll get very used to that number in this unit. All right. So whenever you have a problem, there's always two relationships that you can write down that are related to 1 mole of a substance. All right. The first one relates the term mole to quantity. All right. So this first relationship right here is like saying in 1 dozen grains of rice, there are 12 grains of rice. All right. It tells you what exactly this quantity means. All right. The second relationship is to say, okay, well, if we had a dozen grains of rice, how much would that weigh? All right. What would the mass of that much of the substance be? All right. And hopefully you realize that if we have a dozen of 2 different things, all right, the first relationship is always going to be the same, all right, because it doesn't matter what you have. If you have a dozen of it, it means 12, all right. But for the second relationship, if you have a dozen of something, they're going to have different masses, because if you have a dozen large objects or heavier objects, it's going to weigh more than if you have a dozen lightweight objects or a dozen smaller objects. All right. And that's why one of them is always going to be the same and one of them is going to be different. All right. So let me show you this example on the next page, which I've done. All right. I did this with magnesium chloride. Notice that the first one, so in this problem, notice that the first of the relationships is very similar to the last. All right. You're just saying that 1 mole of something is this many formula units of that thing. All right. The only difference would be, again, is in what you call it. This is an ionic compound. So 1 unit of this is called a formula unit, as in the previous example, a single unit of phosphorus is a single atom of phosphorus. So you say it's that many atoms of phosphorus. All right. But notice that the second relationship is different. All right. It's still related to for example, the phosphorus atoms might be like the rice grains. All right. Again, the first relationship is the same because it's just expressing how many there are. But when you have that same quantity of a larger substance, it's going to weigh more. All right. So that's why the second one has a different number than what you saw right here. This comes from the mass of a single phosphorus atom on the periodic table, whereas this one down here comes from all of these masses, 2 chlorines plus a magnesium from the periodic table. So once you have the 2 relationships written down, you set up a crossbar. And remember, you might need to use both of these. You might only need to use one. It just depends on what the question asks. So you start your crossbar with what it asks, well, what the question provides, which is right here, and you try to use these relationships to get to what it's asking for. This first question would only use this one relationship. You plug it in and you get this number right here. And so again, round to 3 significant figures. I think that this answer is just a rounding difference from the answers at the end. In the last question, or the second example that I gave, notice it starts with formula units, and to solve this particular problem, it actually requires you to use both of the relationships because it asks for the mass, which is like asking how many grams, all right? And when you plug these numbers from the crossbar into your calculator, you end up getting this number, okay? So when you're doing these things, the first thing to do, write down the 2 separate relationships like we have right here, and then try to set up a crossbar that gets you to the answer, all right? Give it a shot. Trust me, it gets easier with practice. And so good luck with that, guys.